This first video on rationalizing square roots in the denominator, we're just dealing with square roots to start with. So for example, suppose I have the problem 4 divided by square root of 2. Square root of 2 is irrational. This would be a difficult problem to do with our traditional way of dividing, because square root of 2 is 1.414. 2, 1, 3, 5, and this is going to go on, divided into 4. I really, as an irrational number, don't know where to move that decimal point, so it's very difficult to do. We're going to change it. What we'd like to do is we always want to get rid of square roots in the denominator. We don't want them in the denominator. We want to transform it so it's no longer in the denominator. What we're going to do is we have 4 over radical 2. If I can multiply square root of 2 by itself, that releases it from the radical. So I'm going to multiply this fraction by radical 2 over radical 2. That's 1. That's equivalent to 1. So square root times itself, it releases it from the radical, we get 2. And then on top we have 4 radical 2. We've done what we wanted. We no longer have a radical in the denominator. But as my last step, this 2 is outside jail. It cancels with this 4 outside, and my final answer will be 2 radical 2. As another example, let's suppose I want you to, and the instructions say, rationalize the denominator. And suppose it was 5 times the square root of 3 divided by 4 times the square root of 50. I could work this problem by multiplying top and bottom by square root of 50, but it might be easier if I simplify the denominator first. If I simplify the denominator, the 50, 2 goes into that 25, 5 goes into that 5, 5 goes into that 1. I can simplify square root of 50, and it's going to become 5 radical 2. This becomes 5 radical 3 over 4, and square root of 50 is 5 radical 2. So my problem can now be rewritten as 5 radical 3 over 20 radical 2. I am now ready to rationalize the denominator. I'm now ready to multiply top and bottom by radical 2. And that radical 2 over radical 2 is really a 1, so I haven't changed the fraction. Working this through, the top becomes 5 is outside. Radical 3 times radical 2 is radical 6. Then I have 20 times the 2 gets released, so it's 40. However, I'm not finished because this 5 is outside the radical and this 40 is. So 5 goes into itself and into 48. So my final answer is radical 6 over 8. We now are ready to do another kind of rationalizing the denominator. And I would say rationalize the denominator. And it might be 4 divided by square root of 5 minus square root of 3. This is a little more complicated. We don't just have one radical. We have radical 5 minus a radical 3. So we're going to think of this as if it was a minus b. We'd like to get rid of both the radical 5 and the radical 3. And I can do that if I can square the radical 5. Radical 5 times itself is 5. And square the radical 3. Radical 3 times itself is 3. And I can do that if I multiply times a plus b, because that is a squared minus b squared. It's a difference of squares, but it will leave me with the square of each of them. So working this out, I have 4 over radical 5 minus radical 3. I am going to multiply top and bottom by radical 5 plus radical 3. I am doing similar to a difference of squares. What this gives me, what I get in the denominator is I get radical 5 times radical 5, which is 5. The inner is negative radical 15 plus radical 15. With difference of squares, the inner and outer become 0. And now minus radical 3 times radical 3 is minus 3. The numerator, I get 4 parentheses radical 5 plus radical 3. I'm almost finished. I can now, keeping the numerator, radical 5 plus radical 3, combine the terms in the denominator. I have a 2, and I'm almost finished. But now this 2 can cancel with the 4 because it's factored out. And this 2 cancels with the 4, gives me a 2, and my final answer can be left like this. Radical 5 plus radical 3 times 2. Or some people distribute it through. That's not necessary.